Well, now let's welcome Jason Fox, Head of Spatial Computing at Worlds.
Thank you.
Thank you. Jason joined the Worlds team after a successful role as Senior Spatial Computing Engineer for Microsoft's commercial software engineering organization. He has experience working with large enterprises to build robust spatial computing systems with technologies such as HoloLens, mobile AR, iOS and Android, and accompanying cloud services. He has designed and built 3D visualization systems, video game systems, non-destructive testing systems, and spends time as a technical evangelist in several disciplines. Thank you, Jason, and welcome.
Thanks. Can everybody hear me okay? Can you guys hear me? I haven't done a mic check yet. Sound good? All right, cool. So thank you for coming. It's going to be a pretty quick talk, but we're happy to kind of unveil what the Worlds team has been heads down building the past couple of years. It's been a fun ride, and we're going to start with a short video. It's about a minute and a half. It's kind of a sizzle reel that helps, set the tone for the talk, and then I'll follow it up with some explanation. So, get started. A lot to unpack in that video. Can I get the presenter notes on the display down here? Thanks. So real quick, before we get into the meat of the platform, I want to kind of tell you what we're thinking. When we start to think about blending the physical and digital worlds together, there's got to be platforms that enable translation and observation of the physical world into a data stream that's usable by end systems. And those end systems could be anything from smart factory systems all the way to like mixed reality headsets, right? And so if you can generate like a really good understanding of what's happening in the physical world, you can make the physical world better, safer, more efficient by augmenting these processes. And so when I present the Worlds platform, you'll see it's a leap in that direction. So this is a little statement we came up with. Worlds fuses together digital twins, spatial data, sensor streams, and artificial intelligence, there we go, into a live data stream of the physical world. The way we accomplish this is through a process or a concept we call active digital twins. And so if you think of what a digital twin typically is, it's kind of a static piece of geometry or data ontology that's, sitting in a system. It usually has some useful information, but like I said, it's somewhat static. Active digital twins are dynamic, right? So you can build a digital twin and then run that in what we call a near real-time simulation. And that's at the core of what we do with the Worlds platform. And so with our platform, you can use our tools, build out a digital twin. You can connect sensor streams, so like video cameras. And then you teach the platform how to interpret that world and then register it back into space. And the process we use to do that is called build, train, automate. And so you build your digital twin, you train it, the system, on how to interpret the digital twin, and then you can use the data generated through that process to gain insights about your world. So with Builder, this is the build step, creating digital twins, connecting sensors. That's really the bridge between the physical and the digital. Right? Get away from that static. This is a solar farm field in Texas. There's actually a drone doing panel inspection up above, right? So digital twin can be really anything. It's not just a building. It can be infrastructure. It can be equipment, all the way down to a cable that connects to a truck, right? In terms of sensing, arguably one of the most important pieces of any of this is how do you monitor, measure, collect insights about what's happening in the physical world and bring those into the platform so that you can run machine learning, you can gain insights and understand what's happening. And so we thought this through, and we wanted to really bring your own sensors. We know that companies invest a lot or have invested a lot in their own IoT infrastructures, security camera infrastructure, and we wanted to be able to enable those to just connect to our platform seamlessly. So video, image, GPS sensors, so things like mobile devices and drones, IoT devices, and then we tried to stay agnostic in that interfacing. The next step with training, after you've gone through the process of setting up your digital twin and connecting your sensors, you want to teach the system what's unique about your space, what's unique about your digital twin and your world. And this is really where the translation occurs, understanding how to combine all that sensor data into that data stream. Because anybody here, machine learning, familiar with it, right? It's got to be trained to certain environments and situations in a lot of cases. So what we've done is we've actually built a set of tools that allow you to quickly iterate on your machine learning models. And so in this case, we're showing video. We have others for time series data, et cetera. But we have a very simple kind of point and click annotation interface. So it allows you to quickly iterate and then get back and kind of validate the detections and the tracking are what you need it to be, right? And so that's a nice iterable process. It's very fast. You train models in the cloud, and then once you're done and they're ready, then you can publish it live and start inferring. Automate. So once you've got that digital data stream set up, what do you do with it? Right? So in the Worlds platform, we allow you to define your business processes. That can be a standard operating procedure. of the like, and tie that into the events that are being generated into this data stream as the output from the build and train process. And so by linking procedures to physical events, that allows you to accurately measure and act upon, like in real time, the key moments in your business process. For example, you can stop the line during a safety event. So if there's some kind of a safety violation where someone's stepped in an area that people are forbidden to be in, there's a piece of equipment that's about to go down, so it's like an IoT case, right? And you need people to clear the area. With our platform, you'd be able to understand spatially those relationships that IoT device is telling me that there's a hazard. I need to warn people, get them out of the area because I know that people are there. Measure cycle time. So not only do you get to kind of take a look at adherence to policy or procedure, you can actually measure the cycle times that your processes are taking and iterate and improve, right? And so what does they say? You can't improve what you can't measure, right? So if we start to measure the physical world in different ways and linking those measurements spatially, you start to gain new insights about your business, your process. So you see here, we're able to take that previous example and monitor that adherence to a standing operator procedure. Oops. Sorry about that. Clicked it a little too early. You can see adherence to a standing operating procedure. So plant managers, process managers, business owners can really take a look at these results and start to get into the bottom of, safety improvements, cycle time improvements, et cetera. And at the end of this, it's not just an enclosed platform. We have an API that allows you to harness this data stream. And so you can pull it into your own platforms, your own analytics platforms, your own business systems, right? So we plug right in. Allow you to do historical analytics, predictive analytics, in a data lake, et cetera. Tie into hardware, so you end up with a feedback loop with the IoT devices, right? So IoT is not just a one-way street. If you want to trigger physical responses in your systems, you can do that. Sorry, there was an animation on there I was not aware of.
Is that your visual?
Yeah.
Did you guys make that, or is that stock?
No, it's all stuff we generated from our platform. Yeah. We do have a rapid start program. So we have a team of solution engineers that can help you walk through this process and get you set up in a very short period of time. I think it's, in most cases, less than a week. We can get a digital twin set up. We can get sensors incorporated into the platform. You end up with that operational 4D digital twin. And then we can start to talk about how do we automate those processes and start to really dig into the insights that are being generated by this data stream. Some of those services, just real quick. So capturing digital twins is an incredibly challenging prospect, if you guys are familiar with it. Also, digital twin means something different to different people, right? It's like the term metaverse. It's like, what does that even really mean? Well, in our case, I said at the beginning, it can be any kind of physical asset. And as long as you have some kind of a reasonable three-dimensional representation of that asset, we can host it in our platform, right? And so it could be a building model, it could be BIM, it could be the model of a car, it could be a model of a drone, it could be a model of a piece of large equipment, it can be a field of solar panels, right? And we can host it in our platform. We register it, calibrate it spatially to the real world. So we use real world coordinates for that. And so you always know precisely where this activity is taking place in lat long coordinates. Right? So that's important distinction to make. So we'll do the site assessment, 3D digital scanning. We have that capability with LiDAR and such as well to help generate these assets. Video capture, maybe you have video camera systems installed, maybe you don't. We can come out and assess the positioning of it, the quality of it. If it's good, that's great. If not, we could recommend how to make it better and install new cameras. The digital twin build, up and running in less than 7 days. And so to learn more, we are a sponsor of the show. We have a booth on the floor, number 724. We have a great team here with us this week. They're all sitting in the back here. Wave, hi everybody. I'll be at the booth if you want to come by, talk shop a little bit this week. And that's it. Any questions?
Hi.
Hi.
Did I hear that based off of the insights that you guys had in the digital twin, that you're able to then push back triggers of actions that can be taken on site?
Yeah, absolutely.
Can you give an example of how that's been done before?
Yeah, so one solid example is, so monitoring a logistics process, they have, kind of the stoplight, the physical stoplight, the LEDs. And so when we gain an insight, we can actually send a trigger down to that light to do a red light stop, yellow light warning, green light go, right?
Awesome.
So like I said, IoT is often thought of as a one-way street. You just want to collect a bunch of data, but there's a lot you can do to trigger occurrences in the real world as a part of your process and improvement. Right?
What's the round trip look like in terms of time? Like how long does that take to go? Insight to action?
I mean, it's seconds. Yeah. So I think right now we're running less than 10 seconds. We call near real time, or that's why we call it like a live or active digital twin, because it's not like true real time. It's not in milli or nanoseconds, but it's getting pretty close.
Thank you.
Yeah. Any more questions?
Question?
What?
Thank you very much.
You're welcome. Thank you. Thank you.